to get started. Okay, cool. Can you click good? Alrighty, good. I can see it just fine. All yours, Nellie. Jump right in.
All right. Hello, everyone. I'm Nellie Tobey. I just recently became the visual learning coordinator here at Kubernetes Community. I started learning coding about 3 years ago. Seriously, I dived into it, and I've been doing art since I was like 10, doodling on my homework, all that. There's a huge overlap in the way you approach art, all the arts really, music and culinary, all the arts really. And there's a huge overlap in the way that you learn and you practice and you gain these skills in art just as much as there is in code and in the sciences, right? So I'm going to go over a little bit of that, and then I'll dive into the coloring book at the end. So this drawing right here is a good example. I was handed a list of keywords about Kubernetes. I've just started learning Kubernetes. It's complex. It's big. It's a lot bigger than anything I've done. So I'm handed these keywords, and there's API, there's nodes, there's cluster, there's PVC, which originally I'm thinking, okay, are we going to learn about plumbing? Because that's where my head went, right? Because I didn't know these terms. So as I'm learning them and I'm looking them up, I'm starting to doodle. I'm starting to draw something. And okay, I know how I can present this in a way that's more relatable. That's not just text that you have to try and like figure out and understand. Like here's an image. This will help. So that's what I'm attempting to do. I'm attempting to make images that will make you connect with the topic beyond just the text, beyond just the complex jargon and text and the documents, and make something that's more friendly and more interactive kind of. So let me go. This is my first time. Finding patterns. This is another way that art and code kind of mesh, right? In art, you're looking for patterns because humans love patterns. We do. We find them, we look for them. It's part of our species, right? To look for patterns. So you do that in algorithms, and you do that in art. I mean, you do it in music. You do it in all of it. We just do that. It's just human. So like the Fibonacci is an example. And the fern on the right is they grow in a Fibonacci sequence, like a cone shell, the spiral. So the leaves, as the fern grows, the leaves on the bottom get bigger and bigger and bigger. And the ones that are starting to grow, they go at basically the same pace, right? But they're starting new, while these other ones are already old and growing. So as an artist, if I had take that drawing or that painting, and I had made all the leaves the same size, if I didn't give it a little twist, it might be unrecognizable as a fern. So that's where you can mix in these things with code and programming, right? I've had someone give me a mock interview, and we did this coding problem, and I'm like, I know there's a trick here, and I didn't get it. And finally I asked him, what is the trick? There's a trick. I know there's a pattern here. I know there's a trick. I just can't see it. And a lot of times that's what it is. You're finding this relationship inside the code and stuff that would fit this pattern, fit what you're looking for, this logical thing that you need to grasp onto and make happen. And it's the same with art. It's the same thing. So here's a quick explanation. So I found these and I thought, okay, these would make a great explanation of visual learning, right? I don't have a computer science background. My first computer class was 2 years ago in the fall at the community college, and it was basically just Microsoft software. That was their computer 101. It was learning Excel and Word and whatever the other names of all those Microsoft ones are. So that's my only exposure to actual higher academic computer classes. Not even in high school, I didn't do computers. So I have this book, and I'm going through the problems. I'm going through solving them. And I reached this one, and the one on the left, you'll see the AAC diagram there, was rotate a matrix. So first of all, I think I know what a matrix is, but I'm not sure. So I went and looked up a matrix. I went and looked up what a matrix was in Python, how to write a matrix in Python. So I said, I need to see this. because I have no idea how we're turning this thing, where the ones in the middle go, where the ones on the edge cases go, where do all these little pieces of information go when you flip it? So I did the diagram on the top, and I have each corner labeled, not with numbers, but with letters, so that when I go to try and imagining it rotating, I can see where the corners go to. So then when I had that done, I could look at it and go, okay, like this, right? And then I could write up the second one where it's rotated. And then I asked a friend, because I wanted to make sure it was right. Does this rotated 90 degrees? And so once I had that, the algorithm was way easier to figure out, because I could see it, because I could map it out with my eyes where everything needs to go and how things need to change. Picture on the right is my little node monsters. I did those in 2017. That's when I first started really diving in and doing Python. I was doing linked lists, and I had just encountered my first encounter with nodes. And it was just this 4 lines of code. And 2 of the lines of the code were more just making them print off in your screen so you could print them off and see what's inside them. So I played with just that, just the class node forever, trying to go, what are these things? What are they doing? What is their purpose? Because it was basically self-guided. I was doing it from a book. So when I had finally written my first stack, written my first queue, written my first linked list, written my first double linked list, I said, I'm going to draw this, because if someone else like me comes into this and they're just like me going, what is going on? I can go here, and I can help them. And I think that's a big part of why I love art. It's not only sharing, it's being able to make something that connects with other people, which is really cool. So that's how we get to the coloring book. The coloring book, I just approach this like I did a lot of drawings. I've been drawing forever, and I would go to the speakers, and I would look at the summaries, and I would look at the titles. I'd look for words I recognized, because there is some stuff in Kubernetes I have no clue, but there were words. A lot of things they were talking about was stuff I had learned about, the databases, the servers. I kind of know what's going on there. So Rick Vasquez is this picture. You guys haven't seen this one yet. But I thought of a database management system. So trees, we love trees, binary, ternary, red, black. We love data trees. So I have the tree growing out of the cube, and I made it a hypercube because it's a complex cube. It's not just a cube. Which, interesting fact, I found out that just when I had showed this to my sister, I found out that hypercubes, you can actually use those in some way to some math trick to index databases. So so I have the hypercube and the tree growing out, and that was the one I did for this talk. Michelangelo and Leonardo, not just artists. These were the original Renaissance man. They didn't just do the art. That's what they're most known for, right? The Mona Lisa, the Sistine Chapel, all the beautiful carvings they did out of marble. But they were engineers. They were mathematicians. They were academics. I mean, the art is the thing they're known for, but they did so much more. And I thought that was a great way to have kind of like, I kind of inserted them in a couple places where I could in the coloring book, because they're just, I think they're great examples of intersections of science and art. So for this drawing, you just listen to it. And I have Mona Lisa kind of morphing into the Cassandra character. And I have all these pipelines, and they have valves, and they have gauges. There's a little leak there. So this is kind of the amalgamation of taking what I could read from the summary and kind of trying to interpret it and give it a picture that would be memorable and fun to engage with. Math and nature, the fern, the Fibonacci sequences I was talking about. Oh, there's math everywhere. So big data and workloads, bees were the natural thing to pick for this, because I mean, they have a highly, not only in their little family working ecosystem, but they're a large part of our whole planet's ecosystem, right? So they built these hives, these shapes, these pentagons, and they got workers, they got drones, they got a queen. It's a really complex system, and they do these really cool complex hives. They build their homes, right? So I thought they were a great example of that, because that not only are they so important to have so much work to do in their own to keep their own system running, they also keep our planet running, because without them, we wouldn't have pollinators. We need them. And so that complex interaction of just not only the tiny system, big system, I thought was a great example for big data. And I'm really happy to be here, and I was so excited about this project, and it was so much fun. Thank you all so much. Let's cuddle some cubes.
Amazing, Nellie. We didn't expect anything less. It's absolutely rocked. We're already getting killer feedback in Slack. We got some great comments on YouTube, because it's exactly what you're doing, is taking these complex concepts, making them accessible, more easily understandable. Folks can do these things with their kids. They can do them on their own. It's kind of like mindfulness. Amazing. All right. So you're going to be getting plenty more artwork today from Nellie, but to stick to our very, very tight schedule, we're going to move on. Nellie,